Tonight, we are going to look for the darkest places in the universe. Not to be afraid of them. There is nothing here that can reach you, nothing that needs your worry. We are only going to visit them, slowly and gently, the way you might walk to the edge of a cliff at night and look out over a dark and silent sea. You can feel how deep it is without ever coming to harm. So let your shoulders fall. Let the day you have been carrying slide off them. You do not need to remember anything you hear tonight. There will be no test in the morning, no thread you must hold. The universe has been keeping these secrets for billions of years, and it will keep them a little longer, whether you stay awake or not. We are going to talk about black holes, the strangest, quietest, most patient things that exist. Places where the rules you have lived by all your life come softly to an end, where light itself lies down and does not get up again. It sounds frightening when you say it quickly, but the truth is stranger and calmer than fear. A black hole is not a monster. It is not a hole that goes hunting. It is simply a place where gravity has won so completely that even light has decided to stay. A still point, a resting place of a kind. Tonight we will fall toward one slowly and learn what waits there. And if you drift off somewhere along the way into the dark and quiet, then you will have done exactly what this story is for. Sleep is its own kind of gravity. Let it pull you down as gently as it likes. We begin at the surface of things in the ordinary night, and we travel inward toward the deepest dark there is. Let us begin with a simple, surprising truth. A black hole is not really a thing at all. It is a place. We are used to thinking of objects in space as things you could, in principle, touch. A planet is a ball of rock. A star is a ball of burning gas. The moon is a stone you could stand upon. But a black hole is different. There is no surface to land on, no shell to knock against. A black hole is a region of space where gravity has become so strong that nothing, not even light, can ever leave once it has fallen in. It is less like a stone and more like a doorway that only opens one way. To understand how that can happen, we have to think very gently about gravity. You already know gravity better than you know almost anything. It is the soft, constant weight that holds you in your bed right now. It is the reason a dropped cup falls, the reason rivers run downhill, the reason the earth circles the sun without wandering off into the dark. Gravity is patient and everywhere. It never switches off. And here is the key. The strength of gravity depends on two things: how much mass is gathered together and how closely it is packed. The earth holds you with a certain gentle firmness. If you could squeeze the entire earth down smaller without losing any of it, its gravity at the surface would grow stronger and stronger. Squeeze it small enough and something extraordinary happens. There is a speed you would need to escape any world. On Earth, that speed is about 11 kilometers every second. Launch a rocket faster than that, and it will break free and never fall back. Slower, and the planet will always, eventually, pull it home. Every object in the universe has an escape speed like this. The more tightly its mass is packed, the higher that speed climbs. Now imagine packing mass so tightly that the escape speed reaches the speed of light itself. Light is the fastest thing there is. Nothing in the universe can travel faster. So if the escape speed becomes greater than the speed of light, then nothing at all can escape. Not a rocket, not a beam from a torch, not light itself. Anything that comes too close simply falls in and stays. That is a black hole, a place where mass is packed so tightly that the universe has, in effect, closed the door. We cannot see it because seeing requires light, and no light ever comes back out. We can only see the absence it leaves, a circle of perfect darkness against the bright and busy sky. It is a strange thought to fall asleep to, that out there, scattered through the dark, are places shaped not like objects but like silences, where the cosmos simply stops giving anything back, We will go closer now. There is no danger in it. We are only looking. Before we go any further into the dark, it is worth knowing that black holes were dreamed before they were ever seen. For 100 years, they lived only in the mind, as a strange and almost unwelcome guess, long before anyone could prove they were real. The story begins in the middle of a war. In the winter of 1916, a soldier sat in the trenches of the Eastern Front, surrounded by the noise and cold and fear of battle, and in his spare hours he worked by candlelight on a problem in pure mathematics. His name was Karl Schwarzschild. Only weeks earlier, far away, another man had published a new theory of gravity, a theory that described gravity not as a force, but as the bending of space and time around anything that has mass. That man was Albert Einstein, and his new equations were so difficult that even he had not expected anyone to solve them exactly, certainly not soon, and certainly not in a trench in the middle of a war. But Schwarzschild solved them. He found the precise way that space curves around a single round mass, a star, a planet, anything. And buried inside his solution was something peculiar. The mathematics said that if you took any mass and squeezed it small enough below a certain critical size, space would curve so steeply around it that it would fold the object away entirely. A boundary would form, beyond which nothing could return. Schwarzschild had found in the equations the first description of a black hole. He sent his work to Einstein, who presented it for him. And then, only months later, Schwarzschild fell ill and died, never knowing what his discovery would one day become. For decades afterward, almost no one believed such things could truly exist. The result was treated as a mathematical curiosity, a quirk of the equations, the kind of thing nature surely had the good sense to avoid. Even Einstein himself doubted that real black holes could form. Surely, he and others thought, some force would always step in to halt the collapse before it reached such an absolute end. The idea was too extreme to be taken seriously. It sat in the textbooks like a locked room no one wished to enter. It took another 50 years and a new generation of thinkers to open that door. They worked out with care and rigor that nothing could stop a heavy enough star from collapsing all the way down, that the strange boundary in Schwarzschild's equations was not a flaw, but a real place that could really form, again and again, across the cosmos. And in the 1960s, the physicist John Wheeler gave the idea the name that finally made it real in the imagination of the world. He called it a black hole, a simple name for the deepest thing in nature, and once it had a name, it could no longer be ignored. It is a quiet kind of wonder to think that the darkest places in the universe were first found not through a telescope, but through a page of mathematics, worked out by a dying man in a trench, in the depths of winter, in the depths of a war. The dark was waiting in the equations all along, patient as ever, 100 years before we ever saw its shadow. Hold that thought softly as you rest. Some discoveries arrive long before the world is ready to believe them. Most black holes were not always black holes. Most of them were stars. To understand the dark, we have to begin with the light. A star, as we said on another night, is a careful balance. Deep in its core, it fuses light atoms into heavier ones, and that fusion pours out a flood of energy, pushing outward. At the same time, the star's own enormous weight presses inward, trying to crush it. For most of a star's life, these two forces hold each other in a gentle, steady truce. The outward push of fusion, the inward pull of gravity, balanced year after year for millions or billions of years. A star is a slow, quiet act of balance, held in the dark. But fusion needs fuel, and no star has an endless supply. Sooner or later, deep in the core, the fuel begins to run low, and when it does, the balance that held the star together for so long begins at last to fail. For a star like our own sun, the ending is gentle. It swells, sheds its outer layers in soft and glowing shells, and leaves behind a small, white ember that will cool for ages. We followed that story before, but for the truly massive stars, the giants 10, 20, 40 times the mass of the Sun, the ending is something else entirely. Something sudden and violent and final. When such a giant runs out of fuel, the outward push vanishes in moments, and gravity, which has been waiting patiently the whole time, finally takes hold without resistance. The core collapses, not slowly. In less than a second, a ball of matter larger than the Sun falls inward upon itself, faster and faster, until it slams together at a quarter of the speed of light. What follows is one of the brightest events in all the universe, a supernova. For a few weeks, a single dying star can shine brighter than its entire galaxy, brighter than 100 billion ordinary suns. Its outer layers are blasted into space in a great expanding cloud, seeding the darkness with the elements of future worlds. The iron in your blood, the calcium in your bones, were forged and scattered in explosions like these. You are, quite literally, made of the deaths of ancient stars. But tonight, we are not following the bright cloud rushing outward. We are following what is left behind at the very center. Because for the largest stars, the collapsing core does not stop. There is nothing left strong enough to halt it. No force in nature can hold it up. And so it keeps falling inward and inward, smaller and denser, until it crosses the threshold we spoke of, and the escape speed passes the speed of light. And in that moment, quietly in the heart of the explosion, a new black hole is born. The star is gone. In its place is a darkness, a few kilometers across, holding the weight of a sun. The light has gone out, and it will not come back. The fire that burned for 10 million years has become the deepest stillness there is. Every black hole is wrapped in a boundary. It has no wall, no surface you could feel, and yet it is the most absolute border in all of nature. We call it the event horizon, and it is worth slowing down here to understand what it truly is, because it is gentler and stranger than it sounds. The event horizon is simply the line beyond which escape becomes impossible. Outside it, far away, gravity is ordinary. If a black hole were to quietly replace our sun with exactly the same mass, the Earth would not be pulled in. It would keep circling, just as it does now in the cold and the dark. Black holes do not reach out and grab. Their pull from a distance is no stronger than the mass they hold. You could orbit one for 1 billion years in perfect safety, as long as you kept your distance. But come closer and closer, and at some point you reach the horizon. And here the nature of the place changes completely. The event horizon is not a thing made of matter. It is a boundary made of geometry. It marks the place where, no matter which direction you try to go, every possible path leads inward. Imagine a river flowing toward a waterfall faster and faster. Far upstream, a swimmer can move freely in any direction. But there is a line, somewhere above the falls, beyond which the current flows faster than any swimmer can swim. Cross that line, and no matter how hard you strive toward the shore, the river carries you down. You are not seized. You simply run out of directions that lead away. The event horizon is that line drawn around the dark. Inside it, space itself flows inward faster than light can travel outward. And since nothing moves faster than light, nothing inside can ever climb back out. Not because something is holding it, but because inside the horizon, every direction in space points the same way, toward the center. The future itself leads inward. This is the part that is hard to hold in the mind, so do not strain to hold it. Inside a black hole, falling toward the center becomes as unavoidable as, out here, the passing of time. You cannot choose to stop moving toward tomorrow. And inside the horizon, you cannot choose to stop moving toward the center. The dark does not pull you. It simply becomes the only place that the future leads. From the outside, the horizon is a sphere of perfect black, A surface that emits nothing, reflects nothing, returns nothing. The size of it depends only on the mass within. For a black hole as heavy as the sun, the horizon is just a few kilometers across, smaller than a quiet city. For the giants we will meet later, it can be larger than our entire solar system. But large or small, the rule is always the same. Cross it, and the universe you knew is behind you forever. There is something almost peaceful in that finality, a line you cannot uncross, a place from which there is no need to return and no way to. Hold that thought lightly as you rest. We are going to cross it now together, and nothing out here will be harmed. Let us imagine very gently that we fall. Not you, sleeping safely in your bed. Only an imagined traveler, a patient explorer who has agreed to drift across the event horizon so that we might know what it is like. We will watch from a safe distance and we will follow them down. The first surprise is that, for the traveler, crossing the horizon feels like nothing at all. There is no wall, no jolt, no sudden cold. If the black hole is large enough, they might cross that final boundary without noticing the precise moment they did. One instant they are outside, where return is still possible. The next they are inside, where it is not. And yet nothing around them seems to change. The stars still shine above. The dark still waits below. The most important line they will ever cross is utterly silent. But something strange has happened to time, and this is where the two views of the fall begin to part. From far away, watching the traveler descend, we would see something eerie and beautiful. As they approach the horizon, their fall appears to slow. Their image lingers, hanging just above the dark, growing dimmer and redder, the light from them stretched and tired. They seem to freeze there, fading, slower and slower, never quite arriving. To us, watching, they take forever to fall. They become a ghost on the edge of the dark, a last frozen image, dimming toward black over the long ages of the universe. But the traveler feels none of this. For them, time runs normally. They fall inward smoothly, without pause, and the center rushes up to meet them. Both stories are true. This is one of the deepest lessons the black hole has to teach. Time is not the same for everyone. Near such enormous gravity, it bends and stretches, and what feels like a few seconds for the one who falls can be 1,000 years for the ones who stay behind. The traveler could fall through the horizon, and in the time it takes them to reach the center, whole civilizations outside could rise and fade. And then there is the matter of the tides. Gravity pulls harder on whatever is nearer to it. When you stand on the earth, your feet are pulled very slightly harder than your head, but the difference is far too small to feel. Near a black hole, that difference grows. For a small black hole, it would grow cruelly, stretching the traveler out, head from feet, into something long and thin. Scientists have a strange and almost tender word for this. They call it spaghettification. But for the great black holes, the giants, the fall is gentler than you might fear. Their gravity changes so slowly across such a vast distance that a traveler could cross the horizon whole and unharmed, falling peacefully inward with the stars still wheeling overhead, carried down without pain into the dark. We will leave our imagined traveler there, falling quietly, time stretching around them like a held breath. We do not need to follow them all the way. Some journeys are kinder left unfinished. Let them drift, and let yourself drift with them, down and down into the soft and patient dark. At the very center of a black hole, our knowledge runs out, and there is something honest, even restful, about admitting that. Not every question has been answered. Some doors in the universe are still closed, even to us. According to our finest theory of gravity, all the mass that falls into a black hole is drawn down to a single point at the center, a place of no size at all, where matter is crushed to infinite density, and the curving of space becomes infinitely steep. We call it the singularity, but the word is really a marker for the edge of understanding. When our equations produce infinities like these, it is usually a sign that the theory has been pushed beyond where it can safely go. The singularity is less an answer than a question we have not yet learned how to ask. We believe that to truly understand the center, we would need to join together our two greatest descriptions of nature: the theory of gravity, which rules the very large, the stars and galaxies and the bending of space, and the theory of the very small, the strange and flickering quantum world of particles. These two great ideas have never been fully reconciled, and the one place in all the universe where both matter at once, where the very large is crushed into the very small, is the heart of a black hole. It is, in a sense, the most important unsolved mystery we have, and it lies hidden behind a horizon that will never let its secret out. So we do not know what waits at the center. Perhaps the matter is not crushed to a point at all, but held in some new state we have not yet imagined. Perhaps space and time themselves come to an end there, the way a question ends when there is nothing left to ask. Perhaps, as some have wondered, the center opens elsewhere, though there is no evidence for it, and we should hold such dreams lightly. The honest answer, the one that is true tonight, is that the deepest part of a black hole is a place we have never seen and may never see, a sealed mystery at the center of the dark. There is no need to find this troubling. The universe is under no obligation to be fully known. For all our cleverness, for all our telescopes and equations, there remain places that keep their silence. And perhaps that is right. Perhaps a cosmos with nothing left to wonder at would be a poorer place to live. Let the mystery be. It has waited billions of years already, and it is in no hurry. Neither tonight are you. Not all black holes are the same size. They come in a great range, from the small and swift to the vast and ancient, and it is a soothing thing, on a quiet night, to let the mind drift across the whole scale of them, from the smallest to the largest there is. The most common kind are the ones we have already met, the black holes born from dying stars. They hold somewhere between a few and a few dozen times the mass of the sun, and their horizons are small, often just a few kilometers across. A thing heavier than the sun, wrapped in a darkness no larger than a mountain. The galaxy is thought to be scattered with hundreds of millions of these, drifting silently between the stars, most of them invisible, most of them never to be found. As you rest tonight, there may be one, cold and quiet and small, wandering the dark spaces of the Milky Way, harming nothing, simply passing through the long night of the galaxy as it has for billions of years. Then there are the giants, the supermassive black holes at the centers of galaxies, holding millions or billions of suns. We will visit them properly in a moment. Between these two extremes, the small and the enormous, there is a stranger, rarer kind, which we have only recently begun to find. The middleweight black holes, holding hundreds or thousands of suns. For a long time they seemed almost absent, a missing link between the small and the vast, and we are still piecing together how they form and where they hide. And then, at the very edge of what we can imagine, there may be black holes of another origin altogether, not made from stars at all, but born in the first fractions of a second after the universe began, when everything was so hot and dense that the cosmos itself could have folded tiny regions away into darkness. We call these primordial black holes, and we are not yet certain they exist. If they do, some of them could be tiny beyond belief. A black hole with the mass of a mountain, squeezed into a space smaller than a single atom. Whole worlds of weight, hidden in a point too small to see. It is a strange and lovely range to consider, from a black hole smaller than an atom to one larger than a solar system, from things born in the first instant of time to giants still slowly growing today, all of them built from the same simple recipe, mass and gravity and the closing of a door, and yet spread across a scale so wide the mind can barely span it. The universe makes its darkness in every size, and scatters it patiently through the long reaches of space and time. You do not need to hold these numbers. Let them wash over you, large and small, near and far. The cosmos is full of dark places of every kind, and not one of them disturbs the quiet of this room, or the slow and easy rhythm of your breathing. So far we have spoken of black holes made from single dying stars, a few times heavier than the sun, only kilometers across. But the universe holds black holes of another order entirely, giants beyond easy imagining, and there is almost certainly one at the center of the galaxy you live in, right now as you rest. We call them supermassive black holes, and the word massive does them little justice. The one at the heart of our own galaxy, the Milky Way, holds about 4 million times the mass of the Sun, gathered into a single dark point. And ours is modest as these things go. In other galaxies, there are supermassive black holes holding billions of suns, with horizons so vast that our entire solar system, the Sun and all its planets and the long, cold orbits of distant comets, could be lost inside them without trace. These giants sit at the very centers of galaxies, and almost every large galaxy seems to have one. They are not rushing about devouring stars. For the most part, they sit quietly, holding their region of space, while hundreds of billions of stars wheel slowly around them across the ages. The black hole at the center of the Milky Way is, tonight, calm. The stars near it trace their long, looping orbits around an unseen weight, the way moths circle a lamp that gives no light. How such enormous black holes came to be is still a story we are piecing together. They are far too heavy to have formed from a single star. They may have grown over billions of years, swallowing gas and dust and the occasional unlucky star, and merging with other black holes when their galaxies collided. Each meal, each merger, adding to their mass slowly, across spans of time that make a human life seem like the briefest flicker. They have been growing since the universe was young. They will go on long after the stars have gone out. There is a strange intimacy in knowing this, that at the center of your own galaxy, 26,000 light-years away, far beyond anything you will ever touch, there is a dark and silent giant, 4 million suns heavy, around which everything you have ever known is slowly, patiently turning. The sun carries the earth, and the earth carries you in a great slow circle around that distant dark, one full turn every 230 million years. You are, even now, in orbit around a black hole, and you have never felt a thing. It does not disturb your rest. It only holds the galaxy together quietly while you sleep. When two black holes find each other, something happens that fills the whole universe with a kind of music. And not so long ago, for the first time, we learned how to listen. Sometimes two black holes are born close together, from a pair of stars that lived and died side by side. And once they are made, they begin a slow and patient dance. They circle one another, around and around, across millions of years, drawing very gradually closer. As they spiral inward, they stir the fabric of space itself. For this is the deepest lesson of that 100-year-old theory of gravity. Space and time are not a fixed and empty stage. They can bend and stretch and ripple. And two black holes, wheeling around each other, send out ripples in space, spreading outward at the speed of light, like waves moving across the surface of a still pond. We call them gravitational waves, and they are astonishingly gentle. As they pass through you, they stretch and squeeze the very space you occupy, making you very slightly taller, then very slightly wider, over and over. But the effect is so unimaginably small that for 100 years, no one thought we could ever hope to feel it. The waves from even the most violent events in the cosmos would change a length the size of the Earth by less than the width of a single atom. And yet we built a machine to feel them. After decades of patient work, scientists made an instrument so sensitive it could measure a change in length 1,000 times smaller than the center of an atom. And in the autumn of 2015, it trembled. The signal had come from two black holes, each about 30 times the mass of the sun, in the final moment of their long dance. After spiraling toward each other for ages, they had at last fallen together and merged into one, releasing in a fraction of a second more energy than all the stars in all the galaxies of the visible universe, shining together in that instant, not as light, as a shudder in the shape of space. That collision happened 1.33 billion years ago, when life on Earth was still no more than simple cells in an ancient sea. The ripples it sent out crossed more than 1 billion light-years of space, washing over countless stars and worlds, growing fainter and fainter, until at last, on a quiet morning, they reached a small blue planet and gently stretched it and were felt. For the first time, we had not seen the universe. We had heard it. A faint, rising tone, a chirp, the sound of two black holes becoming one. Since then, we have heard many more. The sky, it turns out, is not silent. It rings now and then with the slow music of black holes meeting in the dark, a music that has been playing all along, for billions of years with no one to hear it. And now we listen. Somewhere out there, even tonight, two dark giants are circling one another, drawing closer across the ages, and one distant day, long after we are gone, the sound of their meeting will wash, unfelt, across whatever the Earth has become. The universe is full of quiet music. Let it play you to sleep. For most of history, black holes were only an idea, a strange answer that fell out of the equations, so peculiar that even the man whose theory predicted them did not quite believe they could be real. They were too extreme, too final. Surely, people thought, nature would find some way to avoid making anything so absolute. But the universe, it turned out, was not so shy. One by one, the signs appeared. Stars seen orbiting empty space, swinging around something massive and unseen. Great fountains of energy pouring from the centers of distant galaxies, far too powerful to come from stars alone. Ripples in space itself, detected on Earth, sent out by two black holes spiraling together 1 billion years ago. Slowly, the evidence gathered, until there was no longer any honest doubt. The dark places were real. They were out there, scattered through the cosmos, exactly as the equations had promised. And then, just a few years ago, we did something that, for most of human history, would have seemed impossible. We took a picture of one. You cannot photograph a black hole directly, of course. It gives off no light, but you can photograph its shadow. Many black holes are surrounded by a swirling disk of superheated gas, spiraling inward, glowing fiercely as it falls. Against that ring of light, the black hole casts a perfect circle of darkness, the silhouette of the event horizon itself. To capture it, astronomers linked together telescopes from across the whole of the Earth, turning the entire planet into a single great eye. They aimed it at a galaxy called M87, 55 million light-years away, at a supermassive black hole holding 6.5 billion suns. And the image came back, a ring of soft orange fire, uneven glowing, and at its center, a round and perfect dark. The shadow of a black hole larger than our solar system, seen across 55 million light-years of empty space. The first time human eyes had ever looked directly upon the edge of the dark. Later, they turned the same great eye toward the center of our own galaxy and saw the shadow of our own giant, Sagittarius, a star, glowing quietly at the heart of the Milky Way. Take a moment as you lie there in the dark to feel how strange and lovely that is. A creature of a small blue world, gathering the faint warmth of gas falling into a hole in space, half a universe away, and forming from it a picture. The light in that image left its source when the first simple life was stirring in Earth's oceans, and traveled patiently for 55 million years to end its journey in a telescope. And in your understanding tonight, the dark let us see its outline at last, and it was, in its quiet way, beautiful. It would be easy to think of black holes as places where things only end, but the truth is gentler and more surprising than that. The great dark giants at the centers of galaxies do not only destroy, In their strange way, they help to build the very light around them. They are not only graves, they are, in part, gardeners. When gas and dust spiral down toward a supermassive black hole, they do not fall in silently. They gather into a vast, flattened disk, whirling faster and faster as they descend, heating until they blaze. Some of this matter, before it ever crosses the horizon, is flung back outward instead, caught by twisting magnetic fields and hurled away from the poles in two enormous jets. These jets are among the most powerful things in all the universe. Beams of matter and energy, light years long, racing outward at nearly the speed of light, reaching far beyond the galaxy that made them. A black hole, a thing from which not even light escapes, can shine at its edges as one of the brightest beacons in the cosmos. And these jets and winds do something remarkable. As they pour out into the galaxy, they push on the gas around them. They heat it, stir it, sometimes drive it away entirely. And in doing so, they shape how new stars are born. Too much disturbance and the gas grows too hot and restless to collapse into stars at all. The black hole, in effect, can reach across tens of thousands of light years and quiet the birth of suns. The size of the galaxy, the number of its stars, the rhythm of its growth, all of it is bound up somehow, with the dark giant at its heart. We are still learning the full shape of this relationship, but the broad truth is clear, and it is wonderful. Galaxies and their central black holes grow up together, each one shaping the other. The light and the dark, the stars and the silence, woven into a single slow dance across billions of years. The black hole at the center of the Milky Way helped, in ways we are only beginning to understand, to make the galaxy that made the sun, that made the earth, that made you. The dark is not the enemy of the light. It is part of how the light came to be. There is a kind of comfort in that even the deepest darkness in the universe is not simply an ending, not simply a place where things are lost. It is part of the great turning, the endless making and unmaking, out of which stars and worlds and quiet sleeping minds eventually arise. You are here in part because the dark did its slow and patient work long ago in a place you will never see. Here is the last and strangest secret of the dark. Black holes, for all their power, for all their finality, do not last forever. Given enough time, they too come to an end. Even they, in the end, lie down to rest. For a long while, we believed black holes were truly eternal. Things could fall in, but nothing could ever come out, and so they could only grow, never shrink. But the universe is more subtle than that. When we look very closely at empty space at the smallest scales, we find that it is not truly empty at all. It flickers, faintly, with pairs of particles, appearing and vanishing too quickly to ever notice. Empty space is quietly restless, everywhere, all the time. And at the very edge of a black hole, at the event horizon, this restlessness has a remarkable consequence. Now and then, one of these flickering pairs is split apart by the horizon. One particle falls in and the other escapes outward into space. To a distant watcher, the black hole appears ever so faintly to glow, a whisper of light leaking from the edge of the dark, and each particle that escapes carries away the tiniest amount of the black hole's mass. Drop by drop, slower than you can imagine, the black hole evaporates. How slow is this fading? Slower than almost anything that has ever been described. A black hole the mass of the sun would take so long to evaporate that the number of years has more digits than there are stars in the sky. Far, far longer than the present age of the universe. The great supermassive giants will take longer still, vast stretches of time so far beyond imagining that the word eternity barely begins to cover them. For now, and for ages upon ages to come, black holes only grow, but the end is written even so. Across spans of time we have no words for, every black hole will slowly thin and dim, and at the very last, after the stars have long gone out and the universe has fallen dark and cold, they will be the last things left. Faint, fading embers in an empty sky. And then, one by one, in the deepest distance of the future, even they will go. Each one ending not with a roar, but with a final, gentle flicker, returning to the universe the last of what it held. The darkest things that ever existed will be the last to leave, and they will leave quietly, giving back their light at the very end. After them, there is only the long, smooth, even dark, stretching on forever at peace. It is the most patient ending imaginable, and there is nothing in it to fear. It lies so far ahead that the distance has no meaning. We are talking about the destiny of the cosmos, ages beyond ages from this quiet night. The black holes will keep their long watch for longer than you can dream, holding the galaxies together, while countless generations live and rest and wake, none of them ever troubled by the slow and distant fading of the dark. So that is the story of the black holes, the darkest, quietest, most patient places in all the universe. We have learned that they are not monsters, but places where gravity has won so gently and so completely that even light decided to stay. We have watched a giant star collapse into a darkness only kilometers across. We have stood at the edge of an event horizon, a line you cross only once. We have fallen in imagination into the soft stretching of time. We have met the great giants at the centers of galaxies and seen, with our own linked eyes, the first true shadow of the dark. And we have learned that even black holes in the unimaginable distance of the future will one day quietly fade. And through all of it, you have been here, safe and warm, far from any horizon, held gently to your bed by the same patient gravity that holds the galaxies together. The black hole at the center of the Milky Way is turning, slowly, 4 million suns of silent dark, 26,000 light-years away. And you are turning with it, as you have your whole life, without ever feeling a thing. There is nothing out there in the dark that wishes you any harm. The universe is not hunting you. It is only vast and old and quiet and going about its slow and ancient work, while small warm creatures on a small blue world close their eyes and rest. The dark places keep their secrets. The stars keep their light. And the great wheel turns patiently, whether we watch it or not. You do not need to remember any of this. Let it sink down into the dark with you, the way light sinks into a black hole and comes at last to rest. The cosmos has been telling this story for a very long time, and it will still be here, unhurried, when you wake. For now, there is nothing left to do and nowhere you need to be. Let your breathing slow. Let the dark be gentle, and let yourself fall softly into sleep. Good night and rest well, somewhere out here among the quiet stars.